Now, in the last lecture, we have learned the notation called factorial notation. Now, let us go to the part, the title of this chapter indicates that, and that is called permutation. What do you mean by permutation? Permutation is actually very simple. In our everyday life, we use permutation. For example, if there are 4 persons standing, so we arrange them in a row, right? So there is person 1, right? Person 2, person 3, person 4. So there are 4 persons. I have arranged them like this. But how many arrangements are possible? So I can reshuffle them. For example, it can be P2, then P3, then P4, then P1, or it can be P3, P2, P1, P4, right? So these are called separate arrangements. Although the persons are same, but they can be made to stand or sit in a different arrangements. So whenever we are arranging certain objects, right, that arrange in a straight line, right? So we are arranging objects in a straight line like this, right? This arrangement is called permutation. So we can define permutations like this. An arrangement of n objects by taking r at a time. For example, in this question, I had 4 persons and I have taken all of them. So here n was also 4 and r was also 4, but that need not be the case. I may have 4 persons, but I may allow only 3 persons to sit, right? So in that case, r will be 3, right? At a time, at a time is called permutation, right? Denoted the number of such permutations. The number of such permutation is denoted by NPR. It is called, out of n, r numbers are permuted. Out of n objects, r objects are being permuted. That is the meaning of NPR. Okay. So NPR is what? If there are n objects I have, say O1, object number 2, object number 3, object number 4, like that, I have object number n. So there are n objects. But I am not using all of them. I am just using, say, r number of objects. So that is O1, O2, and OR, right? So I am taking only r objects. And actually r objects I am taking means actually what? Actually it means r objects I am filling means what? Actually I am filling up r places. 1, 2, 3, 4, 5, like that. R places I am filling up, right? But I have got how many objects? N to fill R places, right? So total number of such things that can be done, total number of such arrangements that can be done is denoted by NPR. Okay. Now let us start with a concrete example. Okay. So let us say I've got 4 objects. Let us call it A, B, C, and D. But I don't want all 4 objects to be arranged. Okay. So I'll take only 2 of them. So if I want to take 2 of them, how many ways I can arrange them? So A, B, correct? One arrangement. Second arrangement will be what? A, C. Third arrangement will be what? A, D. So A, B, A, C, A, D. Then I will have B, C, B, D. Okay. And the last arrangement will be what? C, D. Okay. So AB, AC, AD, BC, CA. But arrangements can change. So this can be written as BA also. This can be written as CA also. This can be written as DA also. This can be written as CB also. This can be written as DB also. And this can be written as DC also. That means the total number of arrangements are obviously 2 plus 2 plus 2 plus 2 plus 2 plus 2. 1, 2, 3, 4, 5, 6. So it is 6 multiplied by 2, 12 arrangements are there, right? So there are 12 arrangements possible if I take only 2 objects out of 4 objects and I arrange them, right? Now suppose I have got I am allowed to take 3 objects here. So then that will be what? I will be taking first of all say A, B, C, correct? So A, B, C, but A, B, C can be arranged in different ways. So A, B, C can be arranged in how many ways? A, B, C, B, C, A, C, A, B, correct? Then I will interchange A, B, so B, A, C, then I will interchange C, B, so C, B, then I will interchange A, C, so it is C, A, B, correct? So C, B, A, right? So these 3 objects can be arranged in these many ways, okay? If I take only 3 of them, right? But I can take AB, I have dropped D here, so I can take now, I can drop C here, so ABD also can be arranged in similar way. Then ACD also can be arranged in a similar way, and then BCD can be arranged in a similar way. So that means this is 1, 2, 3, 4, 5, 6. 6 plus 6 plus 6 plus 6. That will be 6, 4 times 6. So these many objects are, these many ways I can arrange, right? Now that every time I cannot go on enumerating all the arrangements. So let us simplify this. Actually, we know how to calculate this. Okay. So how to calculate this? Very simple. So go back to our product problems, right? Multiplication problems. Out of 4 objects, I have to only arrange 3. So that is equivalent to filling up 3 places. 3 places are to be filled with the help of 4 objects. So first place, I have got all 4 objects available. So first place can be filled in 4 ways. But one object is already gone. So this place can be filled in only 3 ways. And one object is already gone. So this place can be filled in 2 ways only. And all these jobs are to be done simultaneously. Therefore, the answer is 4, 3, correct? So the answer will be 4 3s are 12 multiplied by 2, 24, as we had expected there also, right? As we have seen the number of arrangements. So if you want to arrange all 4 objects or all 4 objects, then that means you will have to fill up 4 places or 4 boxes. So in this case, it will be 4, 3, 2, 1. But you are familiar with this expression. This expression is called what? 4 factorial, correct? So in general, if I have n objects, A1, A2, A3, and so on, AR, etc., n objects are there, okay? Now, out of these n objects, I want to arrange R objects. It is equivalent to doing R jobs or filling up R places. So this is first place, right? This is second place, second box. This is third box, and so on. This will be rth box, correct? Rth box to be filled up. Now, first box can be filled in how many ways? I got all objects available, so n. Now, here one object is gone, so repetition is not allowed, so n minus 1. So this will be what? N minus 2. Remember, the box number is 3, but I am subtracting 2. Box number is 2, but I am subtracting 1. So box number is R. So what will I subtract? Box number is R. So what will I subtract? Box number is rth box, correct? So here 3, 2, 2, 1. That means from n, I will have to subtract R minus 1. Because if this is 3, this is 3 minus 1. This is 2, this is 2 minus 1. This is 1, this is 1 minus 1, right? So therefore, the last number to be multiplied, and all these jobs are to be done simultaneously. So we apply multiplication principle. So this number, as I already defined, is NPR, right? So what is NPR? NPR is nothing but start from n, go on backwards, right? N minus 1, n minus 2, go on like this till the number of brackets are r. That will be n minus r plus 1, right? So this is how the number NPR can be calculated. For example, if I want to calculate 6p4, fine. Start with 6, go backward. How many times? 4 times, 4 times exactly. So that means 6 multiplied by 5 multiplied by 4 multiplied by 3, correct? So this is equivalent to what? 30 multiplied by 12, which is 360. So 6p4 is equal to 360, correct? Now, this is a very simple way of calculating, but sometimes it is quite laborious, so we can take another way of looking at this formula. For example, suppose I want to calculate 6 factorial. I want to calculate, say, let us say, say 5p3. Okay. Now, what is 5p3? According to this formula, it is 5 multiplied by 4 multiplied by 3. Finished. Right? That is the answer. But suppose I continue to multiply by 2 and multiply by 1. Correct? And in order to compensate, because that will be wrong if you multiply by 2 and 1. So in order to compensate, I'll write 2 multiplied by 1 down also. Right? What is the advantage of writing it like this? This becomes completely 5 factorial. So this is 5 factorial and this becomes 2 factorial. Now what is the relation between 5 and 2? 5 minus 3 is 2, which means I have this formula that 5 factorial upon 5 minus 3 factorial. Correct? I'll give you one more example. Suppose I want to calculate, let us say, 7p4. Now, according to the formula, it is very simple. Start from 7, go backwards, and exactly 4 times you have to do. So 1, 2, 3, and 4. That's the end. If you multiply this, you can get the answer. This is a simpler way of doing it. But I will continue. I'll continue 3, right? It's multiplied by 3, so I'll divide also by 3. Then I'll multiply by what? 2. Then here also I'll multiply by 2. Then here I'll multiply by 1. So here also I'll multiply by 1. So now numerator can be expressed as 7 factorial. Denominator can be expressed as 3 factorial. And that can be written as 7 factorial divided by 7 minus 4 factorial. Now this gives us a very interesting expression for NPR. Okay. So now if I want to write NPR in this new way, then NPR can be written as n factorial divided by n minus r factorial. Very, very easy. Now here you will realize one thing. So if it is n factorial upon n minus r factorial, now this is a very important formula, right? So there are two ways of writing NPR. One is like this, or the other one, as I expressed earlier also, n minus 1, go on, n minus r plus 1. Number of factors here will be r, right? So these two things are same. So this is the formula for calculating permutation of n objects taking 4 at a time. Okay, that is NPR. And what is permutation? Is an arrangement of objects, okay, in which the order is important. If you take AB, it is not the same thing as BA. AB will be counted and BA also will be counted at separate arrangement. So in general, now remember one thing, that I have defined what is permutation. I'll take the summary of permutation. An arrangement of objects in a straight line where order is important is called permutation. That is the first thing that we have learned. Secondly, what is the meaning of NPR? NPR means what? Arrangement, arrangement of n objects taking r at a time. Formula for that is NPR, or it could be n minus 1, and it goes on n minus r plus 1. The base thing we have to realize one thing, that if it is NPN, then it will be n factorial itself. Okay. Now, one interesting thing is that npn is same as npn minus 1 because the last factor is 1. So, if you multiply by 1 or don't multiply by 1, it still remains same. So, npn is always equal to npn minus 1, correct? So, therefore, this is one thing and this is n factorial. Now, if I have np0, what will happen? np0 will be n factorial upon n minus 0 factorial, which will be equal to what? 1. Okay. So these are the things that you have to remember, and in the next chapter or in the next lecture, we'll solve some problems. Okay. Thank you.